Roller Coaster Project by Elizabeth, Kinsey, Alex, and Jonathan. The problem. An amusement park maintenance person is trying to determine when they need to service a roller coaster for safety issues. The given. After 2 million rotations, roller coaster wheels are unsafe and need to be serviced. The roller coaster wheels are 3.821655596 inches in diameter. The roller coaster has gone through its track 2,503 times since the last service. The roller coaster consists of 2 flat sections on the ground, a hill with a flat top in between the 2 flat sections, and 2 loops. The length of the first flat section is 500 feet, and the length of the second flat section is 1,312 feet. The height of the top of the hill is equal to the diameter of the Ferris wheel. The circumference of the Ferris wheel is 628 feet. The diameter of the first loop is 31.831 feet, and the diameter of the second loop is half of the first loop. The flat top of the hill is 100 feet in length. The hill is symmetrical. The height of the drop zone is half of the distance of the hill. A lamppost that is 10 feet tall and its shadow is 11 feet. The shadow of the drop zone is 673.2 feet at the same time. The roller coaster can go backwards and forwards. Each time it goes from beginning to end or end to beginning, it completes a ride. Here's the given information. Solving. First, we need to find the length of the track. The first step in this is finding the height of the drop zone. To do this, we're going to use a proportion. We know the height of the lamppost and its shadow are 10 and 11 feet, and we know the shadow of the drop zone is 673.2 feet. We're going to set up a proportion and cross multiply, and we get the height of the drop zone is 612 feet. We then divide this by 2 to get the hill distance, since that's what it said in the given, and we get 306 feet. Next, we're going to find the diameter of the Ferris wheel. We know that the circumference is 628 square feet, so we divide this by pi to get the diameter, which is 200 feet. We now know that 200 feet is the height of the hill. We now know this information. Next, we're going to find the slope of the length of the hill. To do this, we're going to use Pythagorean theorem. So we do 200 feet squared plus 103 feet squared equals the length of the hill slope squared. And once simplified, we end up getting about 225 feet. We now know this information. Third, we're going to find the circumference of the 2 loops. To do this, we're going to multiply the diameter times pi, and we know the diameter of the first big loop. After multiplying, we get 100 feet, and in the given it says that the diameter of the second loop, the smaller one, is half of the big loop. So we know that 100 divided by 2 equals 50 feet. We now know this information, and we also know the total track length equals 2,512 feet. After finding the length of the track, we find the circumference of the roller coaster wheel and divide the track length by that circumference to find the total amount of rotations per ride. And after simplifying, we get 800 rotations per ride. We then multiply the total amount of rotations of the wheel per ride times the number of rides since the last service. So we do 800 rotations per ride times 2,503. And we get 2,02,400 rotations. The answer. The roller coaster must be serviced after 2 million rotations of its wheels. The wheels have rotated 2,02,400 times since the last service, as our math shows. So the answer is yes, the roller coaster does need to be serviced.